All right, I'm going to get back started here, and then we'll just see where everybody sits down when they're ready. So we're still on top of page 2 for those who are following along in the handout. I was giving you the recipe for the fertilizer. I gave you that. After I put that down is when I integrate my cover crop. Like I said, in many cases I don't need to do that. If I am going to be tilling, I try to keep it as shallow as possible. I really do, if and when I do till, it's really an inch or inch and a half deep, in entirety. It's not a heck of a lot. And so what that means is that this recipe here that I just erased is really worked into the top inch or so. And really does help kick things into gear nicely. Prepare the bed. So I want to talk for a minute about conductivity. Electrical conductivity is one of the pieces of the puzzle that I think Reams was again responsible for bringing forth. I don't think we've got a meter here, so I can just give you a rough outline of what it is. But electrical conductivity is basically a measurement of the amount of ions flowing in the soil, which I like to use. The metaphor I like to use for conductivity is the amount of calories of food per day you've got available. Anybody who's heard of calories might have be familiar with the concept. They say adults need 2,000 calories per day on average, which is just a number out there. 3,000 could be 3,000. Children need 500 or 600 calories per day. A pregnant woman may need 3,000 or 4,000 calories per day. We've got rough ballparks about how much energy you need on a daily basis to maintain yourself. And conductivity basically is that for the soil, for the plants, telling you how much nutrient availability is available for the soil, in the soil for the plants to eat. And what happens is when you got low conductivity, that means basically you have not enough nutrition, not enough food in the soil for the plants to eat. So conductivity is a really good metric for how much your plants have to eat today. And when you see the conductivity drop off, you can be pretty sure your plants are going to stop growing. And then if it keeps going for too long, they're going to get sick and die. So it's a really good proactive monitoring technique or tool. When I grew up on the farm, I never had even the idea that I could monitor in a proactive manner. It was sort of a wait for the diseases to come. Hopefully we've got the next planting coming along, because once the diseases come or the insects come, then the plants die, and then hopefully we've got other planting, cucumbers or summer squash or whatever it is. Conductivity is measured in either millisiemens or microsiemens. I can't remember which one's which. If there was, anybody know milli and micro?
I thought it was Mohs, or did they change it now?
Ohms?
Ohms spelled backwards. Mohs.
Ohms. Reams would call it ohms, I think. No?
No, it was
Resistance?
Mohs.
Yeah, resistance.
Ohms is resistance, Mohs is conductivity. MHO.
All right. The
They
meters
may have changed it to Siemens.
the meters that I've been using, I get from Pike, are measured in millisiemens and microsiemens. Different meters are calibrated in different ones. If one of these was a milli and one was a micro, anybody know which one would be which?
Milli's bigger. So, oh yeah, so that would be micros.
Micro would be 150.
Uh-huh. So that's 10 to the minus 6.
So we want 0.15 milli. Almost caught it. Or 150 micro Siemens, like the company Siemens, is what I'd like to see present in the soil when I plant. In many cases, if you've got a conductivity meter and you go out and you actually stick it in your ground right now, you'll have 30 or 40, maybe 50 micro Siemens, or 0.03 or 0.04 millisiemens. And that correlates nicely with plants that you stick in the ground that don't grow. Anybody ever done that? Put the plants in the ground and sit there for a while? Especially in the springtime? Then the flea beetles come and have their way with them, or whoever it is. My experience has been when you get the conductivity up, the plants grow. And that's one of the cheats that chemical farmers use that works, that organic farmers don't. Right? When you take salt, if you take a glass of water, put the conductivity meter in it, you should have a reading of 0. You take a salt shaker and take one shake of the salt shaker and you go to 500 or 1,000. right? There's nutrient availability in that system now that wasn't present before. And the way it's supposed to work is that the biological activity, the process of biological activity is a process of releasing these nutrients into the solution so the plant has access to them. But if you don't have that biological activity, you don't have a lot of nutrient availability, the plants don't have any food to eat, so they basically are starving to death. Which is what happens when you put your plants in the cold soil and they don't grow. Is they don't have any food to eat, so they don't grow. That's why when you put fertilizer down, and 10-10-10 or whatever, plants jump up out of the ground, because that 10-10-10 is a salt which becomes available and raises the conductivity and the plants grow. It's real simple and it works. It's just maybe not the most elegant systemic way to do it, but it definitely works. Anyway, so I like to see my conductivity start at 150 and then proceed in an upward fashion and plateau through the growing season. And one of the simplest things you can do to monitor in a proactive manner how your plants are doing is to go out once a week with your conductivity meter to stick it in the ground and monitor what your conductivity is. This is what you should see. You should start at 150 plus or minus and proceed upward to a plateau, depending on what your organic matter is, maybe from 250 to 500. The lower your organic matter is, the higher you want your conductivity to be. But you should see this kind of a trajectory, and what you will oftentimes normally see is something that starts way lower, raises up a little bit, plateaus, and then crashes. And you see this, if you're monitoring along and you see this crash, then you can be very certain that in short order this crop is going to start looking peaked or have holes in it, etc. It's a really, really good proactive monitoring system for assessing overall what's going on. I get my conductivity meters through Pike Agri, which we had up on here yesterday. I don't bring it with me on the plane because it's got a little probe. It looks like you'd hurt somebody with it, and I don't want it taken away from me. So the one I have, I think it's cost $89 from Pike. It's shaped about yay big, and it's got this little probe on it that goes into the soil. A little button, turn it on. It's got a digital readout. You push the button, you stick it in the ground, and you get the reading. Boom. You pick it up, you move it over here, put it back in the ground, get a different reading. Push it down 2 inches, different reading. All of a sudden, you can look and see at 2 inches what's available, at 4 inches what's available, at 6 inches what's available. You can watch the nutrients proceed downward through the soil after a big rain. You can see that there's less availability in the middle of the bed than there is in the pathway. Or you can check the outside and the lawn versus the garden. And you can all of a sudden you begin to see and you look and you notice the visual growth, symptomology that's subtle that you wouldn't otherwise necessarily have noticed. You can monitor with this conductivity meter. It's a really interesting and valuable tool if you use it. If you're the kind of person who uses tools. Not everybody is. If you're not that kind of person, don't worry about it. But the point I want to make largely is that it's really important to me to have good conductivity in the soil when I put my seedlings in the ground or my seeds in the ground. I do not want to put my seeds in the ground with low conductivity. So I'm going to give you now a recipe for actually building soil conductivity. This is what I use. Yes?
This tool then teaches you how to read the plants?
It's a really valuable way to begin the process of noticing. I'm not sure if people have noticed, oftentimes in my experience, the middle of the bed, things will be a little bit yellower. They won't grow quite as well as things on the edge of the bed. If you look down the whole field, you'll see areas where things are growing a little bit more well, a little bit less well. You can begin to pattern, you can notice the patterns. It just helps you notice nuances, I think. It's not critical, but it's good to help and see, if you're going to be putting something down, how much is too much, how much is enough. I think when it gets down to it, you should be able to learn. You should be able to know by seeing without having to need tools. But the refractometer and the conductivity meter are the two basic tools I would suggest are really valuable for people who want to begin to establish metrics. Some people like numbers. Some people like spreadsheets. Some people like to have a graph over time of what's going on. And my understanding is this is really a sort of a valuable piece of that puzzle. So the point in general is, what are you putting into the hole to get good biological activity and get good nutrient availability, to cause roots to grow. My thought on this topic in general is that if I'm going to be doing a transplanting anything, I would like to be able to come through and dig up one of those seedlings 24 hours after I put it into the ground, gently reach around the root ball, not rip it up. And I want to see a fuzz of new roots reaching out from the root ball into the soil within 24 hours. If I don't see it within 48 hours, something's wrong. My plant is not feeling excited about getting into the ground. Right? A well-transplanted seedling will have a fuzz of roots reaching out from the root ball into the ground in very short order. That's been my experience. People don't oftentimes dig up their seedlings after they put them in the ground to check and see how the transplant went, but we sort of walk by and say, good luck, guys, or something along those lines, I think, and nothing too much more in most cases. At least that's been my experience. Anyway, quickly, I want to give you a recipe for things you can put into the ground. All of these things are things you can make yourself or you can purchase. I call it the planting or transplanting drench, as in things you water into the ground. Fungal and bacterial inoculant. How do you make your own inoculant? I just want to give you a quick recipe for making your own. Of course, you can buy things. A term to look up online would be IMO, Indigenous Microorganism, it stands for. So there's lots and lots of articles and chapters and books and things on IMOs. But the quick and dirty is that you are obliged to go for a walk. Anybody? Ever feel obliged to go for a walk, or wish they were obliged to go for a walk, or sacrifice their walk because they have other things they have to do? In this case, you're obliged to go for a walk. You can call it, farm time. It's it's legitimate. Like, I'm working, honey. Sorry, not available. I have to go for a walk. What you need to do is you need to bring a bucket or a bag, and the objective is to hit as many microclimates as possible. You want to hit field edges. You want to hit meadow, stream, forest, marsh. You're looking for plants that have shiny leaves. We talked about shiny leaves yesterday, and the fungal. I'm sorry, the fat levels. So the idea is that when you've got shiny leaves, you've got plants that are healthy. When you've got plants that are healthy, that means they're being fed well. If they're being fed well, they've got good gut flora. So wherever you see a shiny leaf, you can know that the biology is functioning well. And so what you do is you just reach down anywhere you see a shiny leaf and pick up a handful of soil from underneath that plant. You want to hit as many different microclimates as possible, hit as many different types of plants as possible: trees, herbs, shrubs, annuals, weeds, moss. Where I live right now, we've got skunk cabbage just coming up in the springtime. Skunk cabbage comes up in the wetland. It almost always has a really nice shiny leaf. Like, there is some biology in skunk cabbage roots that it functions really well at a low temperature, right? That's good stuff. You want to get that, and you want to have it available in the springtime when you're putting your seedlings into the ground into cold soil, because they can use that biology to help feed themselves when the soil's cold. So moss, lichen, lamb's quarters, goldenrod. I mean, just sumac. Just as broad a spectrum as possible. You want to be reaching down any of those plants that look shiny right now, get a handful of that soil, put it in a bag, and go back home, or in a bucket. Generally, I said this before, when you put biology into water, I like to say you got about 4 hours until it's dead. If it's alive and it's aerobic, it'll breathe the oxygen out of the water, and then once all the oxygen is breathed out of the water, it'll die. So you really don't want to keep it in there for any longer than you need to, which means basically you got your bucket of soil, it's the evening, you want to go to bed, fine, that's fine, no problem. Don't put the water in until the morning when you're ready to transplant. But put the water in the bucket, stir it up, and then pour that into your, however you are going to be irrigating or watering into the soil. You can use I use a 55-gallon drum with a sump pump and a hose. I'll put my inoculant in there, I'll put my other ingredients in there, and I'll literally go with my hose and water every hole or water the row. If you've got an irrigation system and you've got drip tape and you made your rows, and you can just, you've got a fertilizer injector, you can put it through the fertilizer injector. If you've got a water wheel transplanter, you can put this in a water wheel transplanter and water it into the rows that you're transplanting. But very simply, you can harvest biology from the environment and integrate it into an irrigation or, a fertigation system to inoculate the soil around your root ball. If you want to make a foliar inoculant, if you want to make an inoculant for the foliage, you go through the exact same process, except you take those shiny leaves off the plants instead of the soil from underneath them. Put those leaves in your bag or your bucket. When you get home, you cover that bucket with water, cover the leaves with water, scrunch them all up, put it in a backpack sprayer, and you can go out and spray that onto the leaves of your plants, and you've harvested biology from the environment, and you can spray it onto your plants. Yes?
I came in late, so you may have covered this already, but what do you think of the rice method?
The Korean natural farming thing where you're going to be
Where you're
meat
culturing
and
the rice
culturing.
with the
And,
IMO?
it feels like a lot of work to me.
You just use some old
I haven't
Mexican
tried it.
takeout, like the little aluminum thing they get, and you go for your walk and put it in that little cardboard cover on it, like.
You say Mexican
I
takeout?
mean, it happened to be, because it was the only collection vessel that I had, I'd carried the soil out of the forest with me, and I like threw it in this Mexican takeout thing, and it was rice and cheese, and oils, the fungal foods, and I was having a workshop, so I put the lid on it, and then it just exploded, so when I learned about the Korean natural farming, I was like, oh, that happened to me.
Oh.
But it was a lot different.
Oh,
you know,
Mexican
but
natural farming, yes.
You can throw it in we threw it in the brewer and extracted it, but it was like a pre-treat, it's the pre-treat.
Yeah, you can reproduce them in that kind of manner if you want to. I think if you're obliged to go for a walk every so often, it's not the end of the world.
So you said that you just take the handfuls and put them in water and you don't aerate it or anything?
If you're going to be using it right away, no, you put them in there, stir it up, and basically all the people in the soil are going to be floating around in the water, and you pour that into your irrigation system.
Cool.
I mean, it can be that simple.
Yeah.
Look up IMO, look up Korean natural farming. There's all kinds of techniques online that are delineated in much greater detail. There's books about this kind of stuff. I want to give you a simple, conceptual idea of what's possible, and then, knock yourself out. Even though it's nice to go for walks, sometimes people don't get around to going for walks, and so having some dry inoculant on hand that you can use in a pinch, I think is not necessarily a bad idea. You can mix your inoculant you've harvested with the inoculant you've purchased if you want. The idea of inoculation is still critically important. Okay, if you want to make enzymes, you can take that leaf tea, those leaves you've harvested, or you can take leaves from, if you're pruning tomato plants or you're pulling weeds, you fill a bucket full of leaves, cover it with water, and put a lid on it and let it sit for, I think, about 6 weeks, 4 to 6 weeks. You need a pH strip, and once the pH in that water has gone below 4.5, you've got a stable anaerobic ferment full of enzymes that can be decanted. You take it, pour it into a 1-gallon jug, put it in the basement, and it'll be shelf stable till next year. You can use it. I like to put a few glugs of enzymes as well into my, transplanting water along with the inoculant. It's
And
one
the
of the-
person that you said, what type were you using the dirt, the soil that you're getting out and putting it in the bucket with water, what do you call that?
I call that inoculant.
But,
IMO, indigenous microorganism,
oh,
is the, indigenous microorganisms is the sort of a general term you can search for online to get way more information than you need. IMO, yeah,
Indigenous is a word that means found natively.
yes, precisely. So it's the microorganisms that are naturally occurring in your local environment, which may be present in the forest and the swamps, but are not present in your field because your field had, corn grown on it for 30 years, and along with that corn, a bunch of chemicals are applied, and the life that was present is no longer present, and so you need to reestablish it.
So going to the edge of the woods would be the best place to go, would be going that way.
Field edges, swamps, meadows, marshes, forests, exactly. Those kind of areas are where you're going to have, where you've got more species of plants growing, where you've got less disturbance. It's where you're going to have more biological activity, and you can basically go and harvest from there to re-inoculate the areas where things have been disturbed.
If you're in like a state park and there's like a nice old rotting log, you see a lot of good fungal strands on, like you
Yeah.
can just get some of that.
I got a bunch of that in my back porch.
Yeah.
That would be good.
Just go out there, leaf, duff.
Put it in your compost pile.
Yeah, you can harvest. These guys are everywhere.
Or just put it in
They're
your bed,
everywhere.
stick it in
Yeah.
My mulch pile sat over the winter, and it was in the end of March, it erupted in mushrooms.
Yeah.
I thought I would deploy some of this mulch, and I went out and put my hand toward it like I was going to pick up a handful of it, and it's like a huge cake.
Yeah.
It is all completely bound up with
Marcia.
Yeah.
mycelia.
Hyphae, yeah.
I have a picture of it, and it is,
Beautiful,
broke it open, and it's almost white.
beautiful.
So what do you do with that?
Use it.
Celebrate.
Pour yourself a glass of wine. A job well done. Yeah.
Use some to inoculate all
What's
your
that?
future
Sugar
pile
and molasses on it.
beds.
Not done yet.
You can bury it in your bed.
Well, I put that same mulch in a new bed,
You stop asking questions, I'll
very
finish.
bunch of it. I got
Keep
mushrooms
asking
in
questions,
it.
we won't get done.
Soil conductivity boost, the IMO drainage.
I'm not there yet.
Thanks.
You can see the ingredient list has only gotten halfway through. If you read the handout and just have a little bit of patience, I may be going somewhere and have done this a few times. I'll stop engaging questions from people who ask too many.
What page are you on, like what?
2.
Here tomorrow.
Pages like 3 through 8 go like, they disappear. All right, so we did inoculation and enzymes. Sea minerals is the next one. We've talked about sea minerals a number of times here today and yesterday. I've made reference to the fact that seawater has this broadest spectrum of elements of any naturally occurring material. Luckily, the planet is covered, 2/3, I think, of the planet is covered with seawater, so we have plenty of seawater to work with. The issue with seawater, if there is one, is that it is the minerals in it are primarily sodium chloride, and people know about sodium chloride, and it's something you don't want to be having too much of. Some is good, too much is not good. There's a really, really simple process by which you can remove the sodium chloride from seawater and just get the trace elements and not the sodium chloride. And it involves, again, you are obliged to go to the beach. You must stay there overnight. You are obliged to go camping at the beach. So this is a farm responsibility. This is a tax write-off for your mileage. You are on staff time. You must bring, I would suggest, a 55-gallon drum and a 5-gallon bucket. You take your 55-gallon drum and you set it up above the high tide line. Take a 5-gallon bucket and fill the drum up with seawater. The only things you need are lye and a stick and a pH strip. You will be adding lye to the seawater in the drum, in the barrel, until the pH goes above, I think it's 10.4. Once the pH is above 10.4, you basically stir the lye in with a stick. You probably want to use a plastic barrel, not a metal barrel, because lye eats metal. And once the pH is up to 10.4, you stop stirring and let it be. You have to go camping, come back 24 hours later, and you should find a milky fluid at the bottom of the barrel. Milky color. In this case, the cream is falling to the bottom, not rising to the top. You need to siphon off the clear water off the top. That's your sodium chloride water. And the milky fluid at the bottom is your trace element rich concentrate. You basically just precipitated out the trace elements from the sodium chloride. It's as simple as adding lye. Nothing else is needed. You can buy sea salt in 50-pound bags or one-ton totes, and you can make it by adding water to your sea salt if you want. You don't have to go to the ocean, but it's a good excuse to go to the ocean.
You still take the sodium chloride out when you are reconstituting sea salt.
If you want to, when you have added water to sea salt, take the sodium chloride out. This is how you would do it. When I'm spreading my 75 pounds of sea salt per acre on the land as an annual prophylactic dose, I don't do anything. I just spread the dry sea salt. But for those who are concerned about sodium chloride, if they want just the trace elements and not the sodium chloride, they're concerned about seawater, this is a way you can easily precipitate sodium chloride out. I have talked in many workshops about the value of seawater. I've got a couple of friends or a couple of people who've taken the course who I thought I was very clear but didn't listen to me. And there's one guy I know who's a wonderful Portuguese guy, and every year he brings me, this 4-pound tomato or two and like a 50-pound winter squash. And he didn't hear my directions, and he adds a gallon of seawater to every barrel of irrigation water. He has a little backyard garden, and so I've said when you're putting together a foliar spray, you want to have a 2% concentration, so that's, chlorocup per gallon or 2 gallons per 100 gallons. He goes to the ocean, gets a 55-gallon drum of seawater, and puts a gallon of seawater into every barrel of irrigation water, and his plants are ridiculous. Absolutely crazy. He is always watering his plants with a dilute concentrate of seawater every single time he waters his plants. It's amazing, and they do ridiculous things. So
Gets stinky because I've tried to bring the ocean water home.
Mhm. it can be a little bit
When I
funky.
close the lid on the jar to bring it.
Yeah,
And it's not bad, it's just the
I don't
pipe
think
breaks
it's
when
bad.
running.
I don't know.
Goes into it.
Microanaerobic. There's a lot of life in seawater. People might not know this, but seawater is absolutely chock full of life. Chock full of life. Anyway, the idea here is basically that you can precipitate that out if you want to. A gallon or 2 of this concentrate per acre would be what the quantities you're looking at when you're talking about watering things into the ground for planting and transplanting. As many as 10 gallons of this concentrate per acre, over the year, watered into the irrigation system, applied through foliar application would be a pretty heavy dose. I've seen people use this kind of stuff and get really remarkable results on their plants. I know all the stories about salt and salt being toxic and salt being bad, and I've also been on farms where people have pushed it with seawater, and I've seen amazing things happen. So I don't know enough to say much about it, except that this is how it works. This is what I've seen, and this is a really simple way to remove the sodium chloride and get just still get the trace elements quickly.
My soil is low sodium.
Yes.
Is this a solution?
Absolutely. Micronized calcium, phosphorus, and traces. My understanding is that root development requires good levels of phosphorus and good levels of calcium. And in many cases, especially cold spring soils, phosphorus is poorly available, calcium is sluggish, and root development is insufficient. So the simplest way to get good levels of calcium and phosphorus is to Calphos or colloidal rock phosphate. You may be familiar with the brown paper bags. They say 030 on them, Calphos, Florida colloidal rock phosphate. If you take that, colloidal means basically very, very small particle size. You can take a couple pounds of Calphos, put it in a 5-gallon bucket of water, stir it up, come back 12 hours later, and that water will still be cloudy because the particle size is so small that it's still standing in suspension. If you put that into your transplant water with the seawater, with the inoculant, you've got a bunch of critical ingredients necessary for good root development. Like I said, when you transplant, you would like to see 24 hours later, you'd like to be able to dig up a seedling and see that fuzz of new roots reaching out from the root ball into the soil. And the conductivity really comes from the sea minerals in this case. Whenever I'm adding a salt, ever, period, end of story, I always like to put in a buffering carbon source. Molasses is possible. I generally use humates at least a little bit. So the traces actually you have good traces levels from rock phosphate. Rock phosphate has about 45 or 50 trace elements in it, similar to azomite. The Calphos does.
Humans have a lot.
Humates have good trace elements in them, absolutely. So what I do is after I made my hole, tested my conductivity, I will add enough for this drench to bring the conductivity up to about 150. That's my baseline. In many cases, farmers who transplant seedlings have this process where they take the tray of seedlings and they dunk it in a mix of liquid fish or kelp. Maybe they'll have it in a water trough for cows or something like that. And they do that because they want to make sure there's a good nutrient pack in the soil when they put the transplants into the ground. My thought is that when you put a bunch of nutrients in the root ball and put it into ground that doesn't have a hell of a lot in it necessarily, that the roots have every reason to go this way and not that way. So my thought is you should be putting the nutrients into the soil and then putting the root ball into the soil afterwards so they have every reason to reach out. Whether you water the hole first or put the seedlings into the hole and then water around it, I don't necessarily care too much. But the idea is that you'd like the roots to have a really strong incentive to reach out, not reach in. Generally, once I've done this transplanting process, I will put my drip tape down and then mulch. And then I'm pretty much done for the year. There's very little left to do. What's that?
But harvest.
Harvest, yes, exactly. I say this, to not necessarily tongue in cheek, but I don't like being out in the beating down sun all day in July or even the end of June. It's wears on you. Anybody spent enough days out in the beating down sun in high summer and felt like that whole sunstroke thing and just like drained, like by the middle of July you're just hanging, dragging. By the beginning of August you're like, why am I a farmer? What I do in the end of June through July is I go swimming back in the ponds, in the stream, in the forest, where I want to be, right? The heat of the summer, you want to be in water. So you walk out back and, hang out in the stream. When the plants are in the ground growing well, the soil is covered with mulch, the weeds can't see the sunlight, they don't germinate, they don't grow. It's real easy. Mulching the soil heavily is something I'm a big fan of. People may have heard of Ruth Stout. Anybody heard of Ruth Stout? Big fan of mulch. I'm a big fan of mulch. I think it really does simplify the whole process. It feeds the soil life. It keeps